Carapace colors change based on the crab's diet, affecting camouflage and mating behaviors. Decapod precision refers to crab's 10 limbs, including 2 pincers, used for various tasks. Crab's blood contains copper, making it blue, and is used in medical research. Extreme regeneration allows some crabs to regrow lost limbs over several molting cycles. Pincer strength varies, with the coconut crabs being strong enough to crack coconuts. Deepest dwellers are found at depths over 3,000 meters in the ocean, surviving extreme pressure. Land migration is observed in species like the Christmas Island red crab, moving in millions from forest to sea. Unusual diet can include other smaller crabs, making some species cannibalistic. Giant size is epitomized by the Japanese spider crab, with a leg span up to 12 feet. Minuscule species like the pea crab can be as small as a pea, living inside oyster shells. Molting necessity is crucial as crabs must shed their shell to grow, becoming vulnerable during this time. Crab communication involves complex claw waving and body movements to signal others. Sand artistry created by some crabs involves sculpting elaborate patterns for mating displays. Temperature change can influence the sex determination of some crab species during development. Migration endurance is seen in the red crab, traveling up to 18 days across rugged terrain. Symbiotic relationships are common, with some crabs hosting sea anemones on their shells for protection. Lifespan variance among crabs ranges from 3 to over 100 years, depending on species. Crab megalopy stage is a transition phase where young crabs are especially vulnerable to predators. Tidal navigators use the moon's phases to time their activities, particularly breeding. Eye stalks provide crabs with 360-degree vision, crucial for spotting predators and prey. Polar inhabitants include crab species adapted to freezing conditions, such as the Antarctic hair crab. Burrowing behavior protects some crabs from predators and extreme environmental conditions. Unique fertilization involves crabs storing sperm to fertilize eggs long after mating. Predator tactics vary widely, with some species using stealth and others brute force to capture prey. Social hierarchy in crab colonies can be complex, with dominant males controlling primary sources. Oxygen absorption through their legs allows crabs to breathe underwater and during low tide exposures. Shell recycling occurs when hermit crabs swap their shells as they grow, often in group negotiations. Nighttime activity is preferred by many crabs to avoid daytime predators and heat. Crab constellations inspired ancient cultures, with Cancer representing crabs in the zodiac. Ultraviolet vision allows some crabs to see hidden patterns on shells and detect predators. Agricultural impact by burrowing crabs can aerate soil but also damage irrigation systems. Sensory hairs on their claws can detect chemicals, textures, and currents in their environment. Salinity adaptability allows some crabs to thrive in both salty seawater and freshwater environments. Crab festivals celebrate the ecological and cultural significance of crabs in many coastal communities worldwide. Protective mimicry helps certain crabs blend with their surroundings to avoid predators. Foraging skills are honed by crabs to find food sources ranging from dead fish to plant material. Territorial disputes among crabs can involve complex rituals and displays to avoid actual combat. Vibrational signals are used by some crabs to communicate through ground vibrations. Larval drift allows crab larvae to disperse widely, aiding species distribution across oceans. Shell architecture involves crabs reinforcing their homes with mud and vegetation. Bioluminescent behavior is rare but observed in some deep-sea crab species, used for attraction or defense. Claw asymmetry results in one larger claw for defense and a smaller one for feeding. Stealth molting is a strategy where crabs hide during vulnerable periods of shedding their exoskeleton. Ancient lineage traces back to Jurassic times, showcasing crabs' long evolutionary history. Crabs gait typically sideways due to the orientation of their legs. optimizing for lateral movement. Hybrid species can occur where different crab species interbreed, resulting in unique offspring. Environmental indicators are represented by crabs, as changes in their behavior or population signal ecosystem health. Intertidal zone is crucial for many crabs, providing feeding grounds exposed by low tides. Chemical warfare involves crabs releasing toxins to deter predators or combat rivals. Collector crabs decorate their shells with materials like seaweed and debris for camouflage.